solution in C++, Java, as well as topics for the in the description. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. Recursion, yes, one of the toughest topics for the beginners is what I'm going to start today. So it's going to be an entire playlist. Do you need to know any prerequisites? Yes, there is a slight prerequisite. You should be knowing what is a function. Yes, what is a function? Like, how do you write a function to add two numbers? You should be knowing that much. If you know how to write a function to add two numbers, that is more than enough to watch this playlist. Will this playlist be in C++ or in Java? Doesn't matter. Just watch this because I'm gonna write pseudocodes and I'm gonna explain the entire concept. So language will not matter. C++, Java, Python doesn't matter. Okay, so to start off with, what is a recursion? Let's read the first line. When a function calls itself, very important. When a function calls itself, that means if I'm writing this function and inside this function, there is this function being called again. So this is what is the definition of the first line. So in order to understand this first line in depth, how does it work and everything, let's take a super quick example to print 1 using a function, like using a recursive function. And once you've understood how recursion works, then we can understand the second line, which states until a specified condition is met. So generally there is a main. If you're using Java, that's a public static void main. If you're using C++, it's an int main. So if there is a main and I'm saying a function, let's assume I write the function as f. Okay, this is what I'm calling, and the f function is a void f function which says, hey, can you please print 1. In C++, it's going to be cout. In Java, it's going to be system.out.println. And I call the same function again. So how does the program runs? First, the program comes to the int main, the execution. Then it comes to the f, and whenever you're calling a function, it straight away goes and calls this function void f. Okay, so I am going and calling this function void f. Now the void f goes and prints this line 1. Yes, it executes this line 1. So I can say if I'm having an output screen, on that output screen at this moment 1 will be printed. Okay, after this line is executed, which states calling of the function, like calling of the self function f. So how will this work? Will it again call back like this, or how will it work? It eventually calls back the same function, but in order to understand in a much better way, what I'll do is, I know like if I just write it over here, there's a problem. So I'll just create a replica of this function and I'll write it over here. Okay, so I'm calling the replica of the function print 1 and again f. So this f again calls the same function. So basically it calls the same function again because this function is in your memory, right? So it calls the same function again, and again this first line, yes, again this first line is executed. So again there will be an output of 1, and again after this particular line will be executed. So how will this particular line get executed? It again calls the same function in memory. So if I write down the f function again, print 1, f again. So this f will now go and call it. Perfect. So again this line will be executed, print 1. So again you print it 1, and again this line will be executed, which again calls one more one line here. There's stand in a much better way. What I'll do is, I know like if I just write it over here, there's a problem. So I'll just create a replica of this function and I'll write it over here. Okay, so I'm calling the replica of the function print 1 and again f. So this f again calls the same function. So basically it calls the same function again because this function is in your memory, right? So it calls the same function again, and again this first line, yes, again this first line is executed. So again there will be an output of 1, and again after this particular line will be executed. So how will this particular line get executed? It again calls the same function in memory. So if I write down the f function again, print 1, f again, so this f will now go and call it. Perfect. So again this line will be executed, print 1. So again you print it 1, and again this line will be executed, which again calls one more same function in the memory, which is void f, and again it prints 1, and after that again calls f. So this, if you write the program, this keeps on going for every day. Why? Because there is no stop condition. Yes, there is not a condition where you say, okay, wait, you're no more going to call me again and again and again. There is no such condition. Thereby, if I keep on writing, this will keep this will keep calling someone, again this will keep calling someone, again this will keep calling someone, and this will keep on going forever. So it's a non-ending recursion, or I can say an infinite recursion, because you're calling the function again and again and again, and there is no specified condition mentioned where you say that, hey, listen, now you're going to stop. So if there is no specified condition mentioned, it's going to fall under an infinite recursion, goes on calling, goes on calling. So if I show you this in my code editor, by the way, this is a Sublime text editor that I use. If you want to use the same format, you can use my watch my video how to install main. You can write it in Java as well. Print is calling cout of 1, which is again a print statement out so much code. So if I show you the code, this was the main, correct? This was your main, and this main called this f, right? This main called this f, and after this f called this guy. So this f, yes, this f is not yet completed. This function call is not yet completed, so it will be waiting in the memory, correct? So the wait, so there is a stack. Yes, there is a stack. You don't need to know any specific definition of stack. Just you can just take it as a thumb rule. There is a stack. Whenever you read data structure algorithms in the next chapters, you'll understand what is a stack. But let's understand this function call. Yes, this function call calls this f, which indirectly calls this. So this function call is waiting. Why? Because this function call has called this. So this will wait. Where does this function call wait? I can say this function call waits in line number 2, because the line number 2 has been called and it is waiting. Now this function call is called over here. You're calling this guy. If you see, you're calling this guy. So apparently another function call with line number 2 is waiting. Now this function call is called, again this guy is called. So another function call at line number 2 is waiting. So if you just keep on calling them, yes, if you just keep on calling them again and again and again, so these particular function calls will be waiting in memory, because they are yet not completed. Now when do you call a function to be completed? If the last line has been successfully executed, but this has not been, because this called this guy, hence the last line has not been completely executed. So this is the wait. This wait is what we call as stack overflow. Now remember, if you keep on calling, if you print one pretty it might go beyond that. When there is, you got it, when a function calls itself. I hope you have understood how the function call calls itself. Now we are going to understand until a specified condition is met. What does this mean? Now if you carefully observe, we call this, then this guy called this, then this guy called this, then this guy called this, then again this guy called this, then this. It will keep on going, but there has to be a condition where you stop calling. Now, that condition is something which is known as base condition. Yes, base condition. So let's quickly write down the function. So assume I'm writing an f, okay, and just assume there is a global variable. I've kept it as count equal to 0, a global variable, okay, and over here I'm writing print count, and I'm doing a counter plus plus, and I'm calling the function, okay. Now if I keep on doing counter plus plus, what will this function like? I've already told you from the main. If I call this function, what will happen? Can you think what will happen? Yes, I think you can. This function call will ultimately call this guy. Then the print of count will happen. And what's the value of count? Initially 0. So the output screen will print 0. Correct? The output screen will print 0. Next counter plus plus will happen. So the counter value will change to 1. And after this function will again be called to f of 0. And again print of count will be called. But this time counter value is 1. So 1 will be printed. Again you'll do a counter plus plus. So counter is increased to 2. Again you'll call this function. And again this will call someone else. So it keeps on going like this. And you'll be doing print count. Counter plus plus again. And again f. So you keep on doing, and again print of count will print the next 2. Counter plus plus will make it 3. And again this will call. This will keep on going. Now you need to stop it somewhere. So the condition that you use to stop it is known as the base condition. Yes, the condition that you use to say that, hey, listen, you're no more gonna call it. You're gonna stop. So assume I say that we're gonna print only up till 3. Assume I'm saying you are going to only print up till 3. So how will you modify it? So you'll basically say function. Let's understand how this works. Right at the starting of the function, you're going to say initially the count is 0. You're going to say if count is equal to 4, I am going to return. Okay, I am going to return. I'll explain you this as well. I'm going to return. Else, I'm going to print count. I'm going to do a counter plus plus, and I'm going to call the function. And in the main, yes, in the main, I'm going to call this function. So if I ask, how will this work? Let's understand. Output screen. Let's see how this works. So I'm saying function. This function is called via main. So it goes and calls this particular function. What's the first line? Counter is equal to 4. Is it? Counter is 0. So counter is not equal to 4. Perfect. Next, goes to the next line which says print count. What's the value of count? The value of count is 0. So you print 0, correct? Next, counter plus plus. That means counter becomes 1. This line is executed. Next, function has been called. So in the stack space, this function will be awaiting. This function will await in the stack space. So in the stack space, this function, which is the line number 1, 2, 3, 4, 5. In line number 5, this function awaits. Why? Because it goes and again calls the same function in the memory, which this time checks is count equal to 4, and then returns. Print again the same thing, counter plus plus f. This time is count equal to 4. No. Print count's value is 1. So to make things simpler, let's keep count as 2 so that we don't have to print a lot of times. Or count as 3. Count as 3. Let's keep count as 3 so that we don't have to print a lot of times. So counter is printed, again counter plus plus. So this line has been executed, function has been called. So the moment you call the function, this guy goes into the stack space saying that, okay, another function call at line number 5 awaits to be completed. So you again go and say f of if counter is equal to 3. Is it? Counter is 2. So it's not. So this line is still not executed. You will print counter. Then you will do a counter plus plus. So print counter will be executed. Prints. Counter plus plus makes it 3. And then again you will call the function. Okay. Now this guy will again go into the stack space. Then you will do a count. This is executed. And you will say return. And you will say return. Thereby, all these. Now, this is we call as a specified condition because you specified that counter has to be 3. Only till then, keep calling, keep calling. The moment the counter was 3, if you carefully observe over here, the moment the counter was 3, you said stop and return. You stopped it. You no more call this function line because you stopped. And due to that stoppage, the other guys also complete. Then you infinite recursion, no more recursion.
Hey, what's up guys, my name is Chano. Welcome back to my C++ C. Hey, what's up guys, my name is Chano. Welcome back to my C++ series.
Hey everybody, let's talk about bitwise operators. These are special operators used in bit-level programming. Knowing binary is important for this topic, so if you don't know how binary works, I would recommend skipping to the next topic. But if you're comfortable with binary, well, this video is for you. So let's begin. I'm going to discuss 5 different bitwise operators: and, or, exclusive or, left shift, and right shift. Let's create 3 variables: x, y, and z. X will equal 6, y will equal 12, and z will store our result, and we will set that to be 0. So I'm going to give you the binary representation of each of these numbers. So 6 is this number. So we have 8 bits, that's a byte. And this is the binary representation of the number 6. 12 would be this binary number. And 0 is easy. That would be all zeros. So let's use the AND bitwise operator. So what we're going to do is set z equal to x and y.
Recursion being called. Go back. So that is what the base case is. You also understood what is a stack. Where the next video will be in the recipe sheet. So before starting this video, plus Java. So today will be the lecture 2 of recursion playlist, which is basic recursion problems. Now, in the previous video, we did learn about recursion in depth. What is like? So please make sure you watch out the previous video, and after that only you start this video. So in this video, we are going to solve some problems. The first one being print name 5 times. I'm assuming you can do that. Print linearly from 1 to n using recursion, definitely. Print linearly from n to 1, then print linearly from 1 to n, but in some backtracking. Over here, I'll teach you how can you do stuffs using kind of backtrack, and print from n to 1 again using backtracking. Okay, so I'm assuming you can do the first 3, but still I'll recommend you to watch the entire video because the concepts gets more clear the more you watch the videos. So let's take the first problem and do it. That is print name n times. Let's keep it n times. Okay, so recursion. So how can you do this? There will definitely be a main which will be calling print. Okay, so I'm saying n times. So what you can do is, so input as n in Java. Over here I'm gonna teach you something which is very important, 1 and n. So this is the first time and I'm saying till n you print it. Okay, over here I'm gonna teach you something, change of parameters, which is very important. So I'm writing a void f. Okay, no global variables this time. I'm taking an integer I and I'm taking an integer n. Okay, over here I know the base cases. If I start from, yes, if I like I have to n times as the problem statement. After that I will be like, okay, let's, so I'll print Raj and then I'll call f. I will, and initially you'll be taking integer n. assume n is given as 3. Assuming n is given as 3. And again, I'll put the output screen over function guy with I is first function. So this guy calls a function back and it go off. I want you to I greater than n and you're saying return, and this time the print statement will be executed complexity and this n times linearly from 1 to n. So basically, if n is given as 4, I want you to print 1, 2, 3, 4. Yes, this is what I want as the output. Okay, so how will you do this? Again, very much similar to the previous problem. If I write down the function print state I, right? When you call I, which is 1, so similar to the and to the next. I think you can print in the opposite fashion. Print in terms of needed. Don't, and I can print minus 1. Definitely. I to have a better simple as that. So it's the main stuff is you just change it over here where you say I'm going to do I minus 1. I'll just print it. These were very basic. I want you to change it and think it in the reverse comma n. I'm saying print from 1 to n. Print from 1 to n, but I am not going to allow you to use plus 1. Like generally from 1 to n was meaning print from 1 to n, but I am not going to allow you to use f of I plus 1 comma n was the function call, was the recursive function call that you were making. I'm not allowing you to do that. I'm not allowing you to do plus 1. So how will you do this? So over here I'm going to teach you something as backtracking. Okay, so let's understand backtracking. Since I'm not allowing you to use plus, you have to use minus. So what I'll do is I comma n. Okay, as usual. This time it will be like if I at any time goes lesser than 1, you return f of I minus 1 comma n, and right after that I'm writing print of I. Okay, so over here I'm writing the main function. Over here I'm writing the main function, and what I'm writing is okay, main. Let's take the input of n, and let's call f of n comma n. So basically what I did was I said that you cannot use this plus, thereby you can use minus 1. Why? Because I wanted me to teach you what if I write the print line after the recursion call. What happens? Let's understand. So again, let's quickly give the output screen and assume n is given as 3. So the first call is 3 comma 3. Thereby the first call goes as 3 comma 3. The first call goes as 3 comma 3. Now let's understand this. Does this line execute I lesser than 1? No, because I is 3 and it doesn't execute. Perfect. Next, I'm saying f of I minus 1. So this function call will go. Remember this. The print line will not be executed. The function call will go. Perfect. Let's call the function call, and I'm saying I minus 1. That's 2 comma 3. And again, let's write if I is lesser than 1, then return. And let's write f of I minus 1 comma n. And then let's write the print of I and then this. Okay. So let's see if the first line executes. Again, no, because I is 2. Doesn't. This time again, you call the function.